All right. Hey, so we're going to do one more example of a limit that doesn't exist, and this one is going to involve something called oscillating behavior. Oh, and I spelled it wrong. Spelled wrong in my notes as well. Can I fix that? There we go. So we're going to look at the function f of x is sine of 1 divided by x. Sine of 1 divided by x. And specifically, we're going to ask, what is the limit as x approaches 0 of that function? Okay, so there's a function, and we're asking what is the limit of that as x approaches 0. So we're going to explore that idea with Desmos. All right, so here's sine of 1 over x. Let me make this a little bigger here. There we go. Here's the sine of 1 over x function. It is a very strange function, okay? It's a bit of an odd one. But we want to know what's happening as x gets close to 0. If you analyze this a little bit, 1 over x should be getting close to like infinity, right? As x gets close to 0, 1 over x is going to be getting close to either infinity or negative infinity if you're talking about x getting close to 0 from the left, right, with very small negative numbers. So if x is getting close to infinity or negative infinity, that input for the sine function, that 1 over x, which is the input for sine, should be approaching, well, what does the sine function do on the left and right side? It oscillates, right? As you look at the sine function going out, like the end behavior is, well, it just keeps on going back and forth between 1 and negative 1, right? So this graph does the same thing. We see up here we're at 1, and then it comes down here to negative 1. I'm looking at the y coordinates here, and it's going to come back up to 1 and then bounce back down to negative 1. And it's going to keep doing that over and over and over again, but the rate at which it bounces back and forth is increasing, which is why we have this really, really like just dizzying kind of graph here where it's bouncing back and forth between 1 and negative 1 faster and faster and faster and faster as you approach 0, to the point where Desmos can't even like render the lines separate from one another because the pixels are bumping into each other, right? There's all these kind of weird artifacts of attempting to render this function. Okay, so it's like where Desmos is malfunctioning almost. Okay, so what's going on here is that if you ask what's happening as x approaches 0, there's no reasonable answer. Like there's no limit that you could assign to that. It just continues to bounce back and forth between negative 1 and positive 1, faster and faster and faster. So we're going to write does not exist on that limit. Okay. So that's actually pretty straightforward if we look at it. It's a weird function, but it's got a straightforward answer. Let's compare that to another function. We'll call it g, I guess, which is the same function except multiplied by x. So x times sine of 1 over x. Okay, I'm going to come in here and I'm going to take this function and multiply it by x. Now we have something that looks very different. All right, in a sense, this is still oscillating, right? Because as you can see, as it gets close to 0, it is still bouncing back and forth, but it's not bouncing between negative 1 and 1 any longer. Okay, I'm zooming out, and I'm going to zoom back in. You can see it's bouncing back and forth, but it's doing so like the maximums and minimums are getting closer and closer to 1 along these straight lines. Sorry, getting closer and closer to 0 along these straight lines. So in this instance, we actually have an answer, right? Even though it's sort of like there's oscillating going on, this is a different function, and this function has a behavior which is very clearly approaching 0. So copy that. If I get back in here and say multiply that by x, now we have a very different result. Even though in a way it's still oscillating, in this instance, that oscillation doesn't mean that we don't have a limit because the peaks and valleys of the oscillation are getting closer and closer and closer to 0, which makes the function approach 0. So yeah, so if you're learning something about oscillation, that's the last of the 3 examples of how a limit can not exist. I think those are really the only three we're going to be dealing with in this class. So that'll do it.